Well, hi, everybody. This is James Pura, and I am joined with Mitch Muncy. And we are here today to talk to you about what's new in the MSC Apex 2021 release. Now, just as a reminder, this is about an hour long. So if you want a shorter, more condensed version of what's new in this release, we also have a video called a highlight reel, which you can view on our website and on our YouTube page. And that's only probably about 5 minutes long or so. So if you want something shorter that just hits the highlights, go ahead and view that. But if you want the nitty gritty details, this is why we're here today. All right, so here's what we're going to go over today. Basically, we're going to start with a high-level overview of what Apex is used for and how you, the customer, is using the product today worldwide. Then we're going to talk about generative design, which is our separate product for additive manufacturing, but it still has the Apex brand on it, so we'll cover it a little bit here. And then we'll talk about the Apex Modeler product. Specifically, we broke it up into basically 5 different sections. We're going to talk about the pre-processing stuff, which is user interface, geometry, and meshing. Then we're going to talk specifically about Nastran interoperability, and we split that into 2 sections, focus on pre-processing and post-processing. And then we're going to talk about thermal expansion simulation, which is really our kind of our crown jewel for this release, our new simulation technology available in this release. And then we'll finish it up with the automation and customization piece, otherwise known as Python scripting and API. Okay. So we'll start by just talking about a little bit about the introduction, who it is you're listening to, and what it is we're going to talk about at a high level. So I am James Pura. I'm the product marketing manager for MSC Apex, if you didn't know that already. And joined on the phone with me here is Mitch Muncy, who is the senior product manager for MSC Apex as well. So I'm going to hand it over to him now.
Thank you, James, and thank you all for your continued support and interest in MSC Apex. So I'm Mitch Muncy, your product manager for MSC Apex, and I'm here for another release highlight. So hopefully by now you're getting used to all the content and the pace at which we're delivering it. And this release is no different. So we're super excited about all the new functionality that we're sharing, but one thing I wanted to highlight was the utilities menu that we added in Apex 2021. With Python scripting, you'd be pretty hard pressed to find something that MSC Apex can't do. And I think the team has done a wonderful job at highlighting some sample code and some examples that show just exactly what we're talking about. If you don't know what I'm talking about, please stay to the end and make sure you check that out. And with that, thanks again, and I'll send it back over to James.
Okay, so let's go ahead and get right into it. Okay, so let's talk about how Apex is being used today for geometry. Worldwide, Apex users are using Apex to clean up geometry because a lot of the time geometry looks different if you're building a finite element model, depending on where the CAD comes from. Sometimes it comes from CATIA, sometimes it's an open source, IGES or STEP. Sometimes it comes from NX or SolidWorks or something like that. Apex geometry cleanup, sketching, defeaturing, and all sorts of stuff in order to manipulate the geometry so that you can get the analysis that you need quickly is exactly how users are using the product. Now, the next topic Apex users are using it for comes as no surprise, which is meshing. Now, the mesh quality that you get from Apex is second to none in terms of other tools out there. So if you're using any other tools for meshing, you're probably spending more time than needed, and you're probably having a less than ideal experience as well, because the user experience for the meshing workflows in Apex are really best in class, and we made sure they were when we developed them. The next one is design trade-off studies, and this is something that is pretty unique to Apex. Because we have a generative link between the geometry and the mesh, and now that we support orphan meshing, there's the link between that as well, is whenever you have a small or medium-sized update where you want to save most of your model, but you just want to change whatever you need to change, Apex is really the tool for that job. It doesn't matter whether you're doing linear static, buckling, modes, or dynamics. It really doesn't matter because when you're doing that for Apex, let's say you look at the analysis type, you're early in the design phase, you're looking at the results and you don't like the results. Well, if you're not using Apex, you probably have to start all over with brand new geometry and then build a new finite element model from scratch. And in Apex, you don't have to do that. You can do things like moving ribs or changing thicknesses or doing this or that or the other thing, actually changing the geometry. The mesh and all the properties update automatically, and you can just resolve. Now, that's only one workflow. The other workflow is, let's say you import a bulk data file from a previous model, and maybe you have an Nastran model or something like that that you want to import and you want to make a quick update to. Now, again, Apex for this design trade-off study is perfect. So let's say you say, well, I think it's going to behave differently if I import this mesh and I add a stiffener rib to it. Well, that's something that used to be science fiction. You probably used to not be able to do that. Well, now in Apex you can, and Apex is definitely the tool for that job. Now, speaking of Nastran, Apex has been rapidly expanding its pre and post capabilities in terms of supporting that solver. And the three ways that our users are really using it for is orphan mesh workflow, results exploration, and pre and post processing for MSC Nastran. So again, you can import a Nastran OP2 or HDF5 results file, just bring it right into Apex without solving it or anything. You don't have to do anything other than just visualize the results. Apex are using it for that. Apex users are also using the tool for importing a mesh and then just rerunning it. Let's say you have an analysis of a part that you ran maybe, or a previous employee at your company ran a year or two ago, and you want to just benchmark it and make sure that you get the same results as they did a couple of years ago, right? You import that orphan mesh. It's already got all the properties associated with it, and you just want to rerun it. Well, you can. You rerun it in Nastran, either externally and import the results, or you can export the bulk data file right out of Apex and then run it in Nastran. Okay, so let's say you wanted to do the exact same workflow, but you wanted to change the loads or change the constraint combinations or any of those combinations. Apex is a perfect tool for that job. Now, the new kid on the block, the generative design, is really for anybody that is either doing it or going to do additive manufacturing. So if you are either 3D printing parts today or thinking about 3D printing parts due to all the benefits associated with 3D printing, then it doesn't matter whether it's in plastic or metals. Apex Generative Design is really the tool for the job, and this has been grown like wildfire around the globe. So another way that really you can sharpen your saw in terms of your Apex usage is if you're doing topology optimization and load path optimization, and you want to do concept and design generation for a 3D printed part. Apex is the tool for the job. Okay, so that's really how our users are using the tool worldwide. Now let's talk about the actual release that we came out with this time. Okay, so here is the high-level overview. You can see that we split it up into 7 different sections. We'll talk very quickly about the new capabilities in generative design, but then we'll go into pre-processing, including UI, geometry, and meshing, and then we'll talk about Nastran interoperability, both from a pre-processing perspective as well as a post-processing perspective, and then we'll talk about thermal expansion and then automation and customization. Okay, so we have a number of test models and demos available to all of you worldwide. So if you talk to your local application engineer or account manager and you see something on this list that was not demonstrated, you can see the ones that are in green. I'm going to highlight those and I'm going to demo those live to you today. But if you say you want to see Nastran beam spans and you want to see the latest demo available of the latest and greatest technology, absolutely you can. All of these demos are available to you now, today. Okay, so let's talk about generative design. Now, in this latest release, we have a cleaner geometry creation process. Okay, so The benefit really is that you can export mesh ready geometry. That's always the finish line, the goal. And we have modified it and made it better with our NURBS geometry export capability. Okay, so both the export and the import were worked on and improved immensely. Okay, so it's a much cleaner, much quicker, and just overall better process. Okay, now the next update is we have a new scripting API. Now this comes as no surprise because the Apex framework supported Python natively. Anybody that was using Apex for Nastran or the internal structure solver knows that the Python API for that tool is extremely powerful. Well, now we have migrated that API over to generative design as well. So now you can start customizing things for your scripting API for your topology optimization as well. Okay. So let's talk about the next thing, which is improved design space tool. Okay, so you can see here that we've got the bounding box of your part here. Okay, so this bounding box basically you can create it very quickly as your initial starting point for your design space inside of Apex, and that is a new technology that we are very proud of. Add that to the fact that you can very quickly Boolean away your part, and you're left with basically everything else that you can use as design space, and you're good to go. You make sure that your design constraints are in there, and your parts that can't be taken away, your little areas like fastener holes and stuff like that, and you're basically there. Now the next thing is symmetry constraint. So before people were running the optimizations inside of Apex Generative Design, and they were looking at this saying, why is it that the left side of my part looks different than the right side? Well, that's because there were slight changes in the load path through your part. Maybe the load was just a little bit off kilter, or maybe through the optimization process, different steps showed that you had the left side look different than the right side, or the top look different than the bottom. And now you can create a symmetry constraint so that both sides look exactly the same. Okay. The next thing is machining allowance. Okay, so think about it like this: like you do an optimization inside of Apex Generative Design, you send it to the 3D printer. The 3D printer prints it. Let's say you printed it out of a very expensive metal alloy. And then you take it to the machine shop, and the machine shop says, well, actually, I have to shave a little bit off this top in order for the fasteners to fit flush. Well, maybe you didn't optimize it, taking that extra material into account. Well, now you can use that. The machining allowance is available for you there, and you can see examples of that in the pictures below in the bottom left there. You can add a machining allowance so that when you print the part and you optimize it, that is already there, that extra layer of material, so that when you take it to the machine shop, the machinist can take that off and create a nice clean surface. And you're not taking away very valuable part that is used in the optimization. Okay. And then the last update for Apex Generative Design is that you have new access and clearance region tools. Basically, if anybody has run into this situation where you have to really bend your arm in a way that it can't be bent in order to put a fastener in or a bolt or a screw in a certain location, if you're putting anything together, it doesn't have to be automotive, it could be aerospace, it could be anything, even involving like your bicycle in your garage. Anybody that's ever done that realizes the value of this tool, because that means that nothing is going to get in the way of the screwdriver in order to turn in that screw or the drill bit or anything else, because you can create those nice quick clearance regions inside of your optimization, and then nothing's going to just like optimize and just create a path of metal right in front of a fastener hole or something like that. So you're covered there. Okay, so all in the name of making optimization and 3D printing easier and quicker and ready for the masses. These are the updates for Apex Generative Design for 2021. Okay, so let's switch gears a little bit and let's talk about the other product, which is Apex Modeler. Okay, And for Apex Modeler, let's put our blinders on and focus specifically on the user interface or UI or UX, sometimes it's called, the geometry and meshing. Okay. Now, when you open up the tool, you're going to see this for the very first time, which is a brand new icon. And you can see it circled in red there with an arrow. Now this works in both pre-processing and post-processing, and it's really cool. I can't wait to demo it for you. So I'm gonna stop talking here. I'm gonna switch directly to the demo. Okay. So in this in the software, you're gonna notice that this new visualization icon in the visualization toolbar up top. There is a bunch of new tools on the right as well. We'll talk about that a little bit later. But for now, let's talk about this exploded view, which you can see I've got a V8 engine imported here, but any assembly with a lot of parts is a complex assembly. You're going to very quickly see the value. We developed this tool specifically for complex assemblies like this, where maybe you need to see something between two parts that are completely covered. Like for here in this piston assembly, I can't really see, if I wanted to define a joint between two parts, it would be very difficult to do. And in exploded view, it's really easy. And then in post-processing, it's the same thing. If something is covering up something else, it's really easy to see that those results on your model in exploded view. Okay. Now, we also had an update in the user interface, which is with every tool panel, you saw this little arrow that said advanced properties with an arrow. And if you clicked on advanced properties, the entire tool would basically disappear. This was not useful basically because users often needed those tools. And it was honestly, we got a lot of feedback that said, well, why have the advanced properties in there anyway? Well, that's because it was kind of a placeholder, right? We wanted to have basic and then advanced. Well, what we decided to do was, well, let's just wait for, that full organization of basic and advanced to come out. And in the meantime, let's just put everything on the default tool so that users don't get caught by hitting that arrow and having nothing left. So that basically just made the tool easier. And you can see an example on that in the bottom right-hand corner, where the advanced properties section is just removed in 2021. And in future versions, you're going to have a basic and an advanced properties section, but we're not going to release that until it's ready. Okay. Now, in the Geometry for Mesh tool, I already mentioned it once in this presentation, but the orphaned mesh workflow is a big deal for us, right? When you want to import a Navstrand bulk data file, or in the future, import a MARC data file, if you have only the mesh and you need to make an update to it, this used to be a very cumbersome, very time-intensive process that was very frustrating, and it required a bunch of different tools. Well, the Geometry for Mesh tool is really that voodoo science section where basically you recreate the geometry from the mesh, and then you can do everything that you would normally do on geometry. And we supported that workflow even more by supporting shared nodes. Now, when you import a Navstrand bulk data file and a set of nodes is shared between two different sections, that automatically gets created into an edge tie when you import it. And then the full circle test is supported as well, where you can export it, and those shared nodes will exist as well. Okay, so everything regarding Apex that you already know and love is already supported. Things like box picking and things like picking things from the model tree, that's all supported. So I think everybody should be very happy with this new technology. We've also had a Geometry from Mesh update in terms of the NURBS geometry creation. And this really came from our Apex Generative Design product, which when you export an optimized part and then you import that into Apex, let's say you wanted to mesh it, the very obvious straight lines and straight edges were being lost. And now we have fixed that, because when you optimize something, and two examples here are that fastener hole. Let's say you wanted to select all the nodes on the inside of that fastener hole after you've already meshed the part, you've optimized the part inside of Generative Design, and you bring it into Apex Modeler. and you say, okay, I just want to run a linear static analysis in Nastran. Why is it so difficult to select all the nodes on the inside of this part? Well, this update fixes that. When you import an optimized part, that handoff allows for first of all, it's a lot faster, but the second thing is that it recognizes machined faces, like the sharp edges, which is really cool, and it makes your workflows much quicker. The next thing in Geometry Cleanup Tool you guys are going to see is facet bodies are supported as well, which this was kind of a hang-up if you were doing the orphan mesh workflow, where you import a mesh and then you wanted to update it and change it. Well, if you wanted to use geometry cleanup, things like finding gaps or overhangs or small edges, you couldn't do that on facet geometry, but you could do that on CAD geometry. And that was kind of a thing that it was a little bit different, right? That's not where we're headed with the product, which means that you should be able to do everything regardless of whether it's geometry for mesh or original geometry. And we're getting there. We're not quite there yet, but every release gets us closer and closer to that finish line. And this is a huge step in that right direction. Now, the next thing is cliff fillets. Now, this is, during our beta test phase, got immense praise from our beta testers. Everybody loved it. And a cliff fillet is really, it is really not a fillet in the strictest sense of the word, because the two surfaces that the cliff fillet connects, if you extend them, never intersect. Okay. If you look at a normal fillet on the top left there, kind of in the middle of the slide, you can see that the two adjacent faces, this is really easy to defeature mathematically, because if you take the two surfaces and extend them, there's clearly an intersection point. Well, if the cliff fillet disappears here, you don't really know what is supposed to happen here mathematically, because if you do the exact same algorithm as before, you don't end up with a nice vertex or a nice seam or intersection of those two planes. So what we needed to do was to develop the tool so that it realized that this ended up being a 90-degree angle or whatever else it ends up being. And now we have an enhanced defeature tool. Both the by face and the by identified feature option, they both work, and you can see examples here. And then I've got a demo for you showing the example as well. So for this demo, we're basically highlighting that defeature tool that has been available. You can see that this is Apex 2020 Feature Pack 1, so the previous release. And you can see some cliff fillets right there that it didn't even identify them, okay? And I was using the by identified feature in this example. So now if we switch to Apex 2021 and I do the exact same defeature, by identified feature, I select it, and I click on fillets. Sure enough, look, it identifies the cliff fillets. Not only that, but if I execute and I say defeature them, it will defeature them, and it'll turn the geometry into what I want, which is that nice, clean, defeatured face. Okay. So the mesh control points and curves. Let's talk about them now. One of the drawbacks to mesh control points and mesh curves when we first developed it, this is actually a relatively new technology, because let's say you don't want to change the geometry, but you want to control the mesh. Well, that is exactly what mesh control points and curves are for, which means that, look, I've got a surface, I've got a nice clean surface, it's creating exactly the mesh I want. I don't want to change the geometry at all for whatever reason. Well, you create a mesh control point or a mesh control curve, and you can do exactly that. The problem was that when you transformed it, let's say you wanted to copy and paste it, you had 4 wheels on a car, and you wanted to dial one of the meshes in and then transform 3 more. Well, you couldn't do that, right? You had to redo the work and repeat yourself over and over again in order to get the job done. And now you don't have to do that anymore. So the transform tool is now supported, and it works for mesh control points and mesh curves. Okay. Now, also in meshing is an incremental meshing improvement, which means facet body support. So in facet bodies, we have an improved meshing algorithm. and the incremental meshing workflow. If you haven't used it yet, basically, if you have features of your geometry that you need, say a washer mesh or a nice clean edge mesh or something like that, the incremental meshing workflow allows you to do that. And previously, this only worked on imported geometry from, say, CATIA or SolidWorks or Step or IGES. And if you had a mesh and you recreated the facet body from that mesh, this incremental meshing workflow didn't work. And now it does. Okay, so that's a nice improvement. Also, with meshing improvement, we have updated the meshing from geometry that is output from Apex Generative Design. So let's say you export a nice optimized part. One of the cool parts that we tout as a strength of Apex Generative Design is that you get mesh-ready geometry. Well, what we didn't talk about was the quality of that mesh once you actually mesh the geometry, right? So that was kind of the next step of evolution of this tool. And Apex 2021 gets you there quicker and better because the mesh quality is much higher. Okay, and this works for both surface meshing and solid meshing. We did a lot of benchmarking behind the scenes, and now you have a nice, cleaner and quicker workflows. Okay, now in terms of shell meshing, we have a new default setting. Okay, so if anybody has been frustrated with the default settings before, just know that if you contact us and let us know that you don't like the default settings, we will consider changing it. And this is a great example of that because we came out with a new option called Mesh Flow Optimization, and it was not on by default. And our users loved it. We tested it a lot more. We gained confidence in it. And sure enough, we loved it so much that we turned that into the default setting. So just know that if you upgrade from Apex 2020 to Apex 2021, you will automatically see nicer, cleaner, better meshes all around that really form to your geometry. And you can see an example of this where in Apex 2020 Feature Pack 1 with Mesh Flow Optimization off, you can see that this is the type of mesh that you would get. And look at all of those, poor and bad quality elements. And now if you use the default setting with Mesh Flow Optimization on, we have 0 bad elements, okay, on that exact same piece of geometry. And then you can see another example here where the washer mesh just turns into something that is more along the lines of what you would originally want as your completed, nice, finished mesh. Also look at the nice, clean edge mesh of one layer of elements that follow the curvature of the part as opposed to all of this kind of nonsense happening over here. So you just get overall, you get a better mesh. Now, in face mesh growth transitions, we made an improvement as well. So let's say you have a really small element size along a geometric feature, and then you have a default element size which is much bigger. You can actually control the step and the change, the transition from the small to large, or vice versa. And that is a new capability on both solid mesh and surface meshing. You can play around with this little dial, and you can change the face mesh growth factor and really dial it in how you want it to. Okay. Now, the ability to move orphan mesh between bodies and parts. This is something that was kind of hidden in the release, and we decided to really make it a capability here that everybody should know about. Okay, so you can see a clear example of this is down at the bottom. You see you have an original mesh on the bottom left. You have a selection of elements, a sub-selection of elements, okay, here. And if you want to separate and reorganize that and it was an orphan mesh, you couldn't do that before, okay? If it was you were unable to separate and reorganize an orphan mesh if you imported it as a single connected mesh. Well, now you can, okay? And that capability is here. Basically, what you do is you right-click it, you change your pick filter to element, you either box select it or you click them together, and you can do this alt drag or drag the set of elements to a new part in the assembly tree. Now, anybody that uses the assembly tree inside of Apex, which is all of us, knows that that is deceptively powerful, right? You can do things like copy and paste and drag and drop and all this really cool stuff. And this capability is also there as well. So if you have an orphan mesh and you want to drag and drop and reorganize and reparent certain submeshes for orphan meshes, we got you covered. Okay. So let's talk that's geometry and meshing. Now let's switch gears a little bit and talk about Nastran pre-processing and then Nastran post-processing. Nastran pre-processing had an additional update in terms of beam spans, meaning that you can actually orient your beam spans with a vector now. And you can see some examples here that you've got a new radio button where you can orient your shape based off of a vector and not just off of an angle. And then you can, in your property ID, you can enter that as a field, or you can enter it as a single ID or an element ID. It's up to you. Okay, so you've got three types of definition in terms of imported property ID. And if you have a variable property ID, it'll be stored in tables and fields if you're at that level of sophistication. Okay, so we're getting there. But when you import a Nastran orphan mesh and you've got these vector-oriented beam spans, we've got you covered. Now, an additional update to MSC Nastran is mesh-dependent tie enhancements. Okay, so in Apex 2020 Feature Pack 1, up in the top visualization toolbar, you saw this icon that kind of looked like a T-junction of elements. And if you hit the arrow next to it, you had all of these different options, right? Including 3 different renderings for mesh-dependent ties. Well, we simplified it, okay? In Apex 2021, due to the new capabilities, or basically the lack of restrictions, now you have the ability to show topology rendering when edge ties are present. Okay, before you had an additional capability. So you had a lack of capability, and now that we fixed that, now you can render your orphan mesh with edge ties better, if that makes sense. Okay. All right, so let's talk about Nastran pre-processing in mesh-dependent and specifically mesh-dependent tie exports. Okay, so in the previous release, you had this option where you would choose a pull-down menu of mesh-dependent tie rendering connecting with R bars. This is basically because PDF files, you previously weren't able to export shared nodes. And now you can. Nodes can be shared between parts, and because Apex 2021 supports shared nodes between parts and edge ties are supported as well, we just decided to simplify the bulk data file Nastran export form, and now that option is just really no longer there because you don't need it. We've also got a bunch of improvements in terms of performance, in terms of import, export, edge tie processing, mesh-dependent tie processing, Nastran large models, both aerospace and automotive models that were very, very big, and in terms of making sure that Apex handles them robustly and quickly. We're always pushing the envelope in terms of what Apex is capable of handling in terms of Nastran models and rendering and rotation and all that kind of good stuff to make sure that you guys have a good user experience. Okay, and the example that I really like to highlight on this slide here is that importing a Nastran results file from an HDF5 file, we had a benchmark model that moving from 2020 to 2021, importing that results file was 10 times faster. Okay, so that's just that's one example of many of us improving both Nastran and Apex becoming best friends and working together a little bit easier. Okay, so let's talk about the belle of the ball, or really the crown jewel of this release, which is thermal expansion. This has been in the works for a while now, and we are pleased and very proud to release it to our Apex users globally now. thermal expansion is now supported. Both the internal solver as well as the external Nastran. And not only can you create a thermal expansion analysis and run externally in Nastran, but if you had a Nastran deck that had a thermal analysis in it, Apex has the ability to import that and recognize it and manipulate it. You can change loads and fields and initial temperatures, everything that you would want to change. Apex supports now. This is very robust. This is new technology, and our initial testing has all of our customers very happy with the original with the initial release of this. Yes, we will continue to make it better, but for now, you guys have initial temperature, you have a loading temperature, and it works regardless of whether you run it externally or internally. Okay. Now I'm going to skip through a few of these because most of these just make perfect sense, which is thermal expansion. If you use Patran for thermal expansion, the Nastran export looks exactly the same. On your MAT 8 card, you would have, or MAT 1 or MAT 8, doesn't matter whether you have isotropic or orthotropic materials. The thermal expansion is there. Also on node ties, if you tie nodes together from different parts or different sections of your mesh, you can define the thermal expansion coefficient for that node tie. Say it's an RB2 or an RB3, very similar to what you would have for Nastran or Patran. Okay. Unit systems, we had to add a bunch of different unit systems in order to support radians, degrees Fahrenheit, as well as degrees Celsius and Kelvin. Okay, so all four of them are supported, and they're not only supported manually in the user interface, but they're also supported using the Apex API, the Python API for scripting. Okay, so this is just another example of what it looks like. You've got the thermal loading temperature as well as the initial temperature. If you want to do a thermal soak based on initial temperature, you can totally do that now inside of Apex. In fact, that is part of the demo that I'm going to show you here. So here is how you can set it up in the scenario. You can have multiple different thermal loadings. So it's not just an initial and a thermal load. You can actually do additional thermal loads, and you can do different events using those different temperatures in the loads scenario manager. Okay, so here's what it looks like in the model tree. You can see here if you double click the default temperature settings, you can see the initial temperature as well as the load temperature, and you can organize them per scenario or per event, totally up to you. Okay. Okay, so let's look at a demo of thermal expansion, of a very classic example where you have two metals and you heat it up and you see one has a different CTE than the other, and it starts to curve depending on how the different metals expand. Okay, so let's go ahead and click play here. There we go. All right. So in this demo, like we talked about before, we're going to look at a thermal expansion, which works both the internal solver as well as external solver, MSC Nastran, and it works exactly the same no matter which solver you're using. Okay. So it also works for both metals and composites. And so we won't be able to really go into all the details here in this demo, but at least here you can see on this classic example model, you define your CTE and your coefficient of thermal expansion, and the metal that has the lower CTE expands less, and the metal with the higher CTE expands more, thus causing a curvature of the model, and you can see there. Okay, and so we're looking at the post-processing results of that metal strip. Now let's look at a more realistic, real-world example of this thermal expansion technology, which is an aircraft soak analysis, where we basically look at an aircraft or an aircraft's wing or an aircraft's fuselage sitting in ideal conditions, which for this example is 20 degrees Celsius or 70 degrees Fahrenheit. So maybe it's sitting in London in springtime. Okay, it's 20 degrees Celsius. Well, let's apply a delta to it. For example, maybe the plane is instead sitting in a hot desert, say like Cairo, Egypt, in the airport on the tarmac, at the peak of summer. Okay. And for a typical thermal soak analysis, we would apply a 20-degree Fahrenheit delta, and here you can see those results. Okay. So now with this capability, you can basically do thermal analysis on both metals and composites, and we've got you covered. Okay. So now let's switch to MSC Navstrand post-processing. Okay. Let's talk about the new capabilities there. The first thing is that you now have a cross-section force sensor array. So let's take that aircraft wing example again, where you look at this and you say, okay, well, I want to create a cross-section sensor at the exact same interval from beginning to the end of my aircraft wing. Well, now you don't have to create each one one at a time manually. You can actually just create an array of these, and this shows you where that is. It's on the same cross-section force sensor tool, but now you have a new icon of an array, and you basically just define either the centroid or you define the path, and everything's pretty self-explanatory at that point. Okay, and then in post-processing, once you're created those, you can post-process them by looking at them by just double-clicking on them in the model tree. Okay. Now, you also can control this cross-section force sensor array via a Python script as well, so you don't actually have to create them manually. You can create them using a script as well. Okay. The next technology, which I'm most excited about, is shear bending moment torque diagrams, otherwise known as VMT or SMT diagrams. These are in the XY response charts, and you can see an example here. And it's just got a whole lot of capability here. Okay, now you can finally see the shear bending moment torque of your finite element model. And just like the rest of Apex, you can do it on an assembly, or you can do it on a specific part. You can do it on a specific sensor, whatever it is that you need. Apex has that visualization update automatically. And not only that, but if you switch in the model tree and you have shear bending moment torque diagram up and you double click a different part, the diagram will automatically update and refresh for you, so you don't have to go through the entire process of recreating the chart, which is a big frustration, which you no longer have to experience. Okay. Now in Apex, in addition to this, we have multi-view and charting, and you can see examples of this, and I've actually got a demo to show you here in a little bit that shows you really the capabilities of the multi-view and charting when it's combined together with the sensor arrays and the shear bending moment torque diagrams, okay, which is pretty cool. It's something that we've been building for a while now inside of Apex, and we finally released it, and we're very proud of it. It's very exciting. Something that our Navstrand user community has been asking for a very long time, specifically since the moment we started supporting HDF5 files, is when will the legacy OP2 results file format be supported as well? A lot of our Navstrand users have been Navstrand users for a very long time. Okay, and they said, look, HDF5 is great and all, but it's kind of the new kid on the block, right? I've got a whole hard drive full of OP2 files that I do not want to rerun just to get a new, different results file format. Well, now we've got you covered. You can import either just the results or the model and the results, okay, and you can post-process OP2 files in addition to HDF5 files. And here is the example of that. So in this same example, we're basically showing you importing OP2 results files and shear bending moment torque diagrams and the multi-view capability. Okay, so let's see what we're showing you here. So here I'm going to import an OP2 file. Okay, so just showing you that I'm not faking anything. So I'm going to import an OP2 results file format, and if I expand here, you can see the file export. The file extension is OP2, and I'm going to organize by contiguous mesh region, and I'm just going to hit import, and sure enough, those parts imported. So it doesn't look like I actually organized by contiguous mesh regions, but I organized by. Oh yeah, I did. Okay, yeah. So we're good here, and then what we're going to do is we're going to create a shear bending moment torque diagram as well. But first we're going to create a sensor array, which you can see here, and then open up the response chart on the right-hand side. Okay, so here you can see an example of both of those technologies working hand in hand together, where basically we show a vector plot of the cross-section force sensors on the left, and on the right you're looking at the shear bending moment torque diagram, which shows the response of each of those sensors, or each of those locations of the array. Okay. Now we can even expand it even more. Not only can you have 2 views, but let's expand it to 4 views. And instead of the vector plot, let's instead look at the beams. Okay, and let's look at the beams at the same time as looking at the cross-section force sensor array. And let's do the same thing. Let's look at some responses on the right-hand side. And sure enough, everything updates automatically, regardless of what you select or pre-select. All you got to do is hover over different sections of your model, and the results will automatically show up. It's a pretty powerful tool. So for those of you that have been waiting for this technology to come in post-processing, we've got you covered. All right. So let's talk about the last section, last but not least, which is a powerhouse of technology relating to the Python scripting available inside of Apex. Okay, so now we finally supported the middle mouse button execute apply command inside of Apex. Why is this important? Well, let's say you write a script where it requires the user to interact with your model. Let's say you say, okay, that you write a Python script, and the Python script says, okay, user, please select the parts that you want to perform this command on. Well, if you create that script, the script will ask the user for that, and then you can add this in, and then you can execute after that happens in the script, which is something that was missing and is now delivered. Along those same lines, we now have lightning bolt support as well. In the manual mode, you know that there's lightning bolt where if you check it on, there is no middle mouse button required. And now we have that supported inside of the Python API as well. Now, probably the biggest thing to be available inside of the scripting, well, it depends on what kind of scripts you write or what kind of scripts you use. But inside of Apex, we have custom tool palettes available. And here you see the ability to create multiple tool palettes depending on what tool palettes you want to create. Before, users were getting really frustrated because they would write tons and tons of scripts, but it would be required to be on the exact same tool. But now you can create your own. And a fun little example that I included here is you can actually include your own icons as well. You can customize the icons on your custom tool palettes and make it look like a little spaceship or a little happy face or a little wrench or whatever it is you want it to look like. You can create it that way. Okay. Now, the automation and customization also has the ability to scale your palette or group or tool definition by you can define the palette, you can define the group, you can define the tool, and it just gives you additional capabilities of customizing your Python scripts built into Apex. Okay, gone are the days where you have to do file run Python script for every single script that you write inside of Apex. Those days are long gone now. Sure, you can still do that if you want to, but that's not really how most of our users are using it. Now, something that came out of our early days of Apex scripting was the ability to use Apex as a module and not just run, because Python is such a powerful language in terms of scripting and automation and customization. Our Python early adopters inside of Apex came to us and said, look, I want the ability to run Apex as a subsection of my master Python script. Let's say I run a Python script that calls apart from CATIA or NX or SolidWorks and then closes that application down and then pulls up Apex. I want the ability to control Apex as a part of my Python script. I don't want to have to double click and open up Apex as the only environment to run my Python scripts. Well, now we got you covered there. Okay, so we call it, it's a really cool name, we call it remote control. So you can pick up the remote control and you control Apex just like you can control your TV, and you're good. All right, so a couple of examples here. The first example is when you're developing a custom script or a batch script it is really useful to use this to be able to step through the Python code line by line using a debugger, and you can do it interactively, which is new available with this Apex remote control. Example number 2 is when you're using Apex as a simulation service to support another application. Okay, so let's say you're opening up Patran and you want to invoke Apex from Patran. You can do that. Okay, either within Patran or within Mentat, or you can do it externally using an external standalone Python application. Apex Remote Control has you covered there. Okay. Now you also have the ability to either show or hide the user interface. This is also something that early adopters of Python inside of Apex requested of us, which is the ability to, it really bogs down your computer when you are showing the user interface for every single Python command that you want to run. Let's say you just want to run 3,000 parts inside of your assembly file. Well, it requires a lot more bandwidth on your computer if your screen is actually showing all 3,000 of those parts being meshed, and now you don't have to do that. Okay, so you have the ability to hide the user interface if you're doing things like that. Okay, now the example here that I'm going to show you is the Apex Utilities menu. Okay, so we didn't have enough time to really show you a demo of every single new capability, but Apex has this new utilities menu here that has a bunch of built-in Python scripts that does not come from product development. Okay, so over the past couple of years, we've had a Python API, and because we've had that, we've had a number of our Apex scripting community build scripts that here at MSC, we look at those scripts and we're like, man, those are cool. Everybody needs the ability to use that Python script. It's so cool. Let's say you want to run a script and it just automatically creates a bunch of materials, right? That script is now shipped with the installation of Apex, along with a bunch of other scripts you can see here of creating, starting geometry or creating fasteners or all that kind of good stuff is now supported. So I want to reiterate, though, that these are not MSC product development delivered capabilities. Okay, these are Python scripts that were developed by the user community, including people that are watching this video now. Thank you very much. We very much appreciate it. And now all of the Apex user community thanks you as well, because now they no longer have to email you every single time one of your older scripts doesn't work anymore, and they don't have to say, hey, Larry Pierce, or hey, Stefan Tenelius, your script no longer works. Can you send me the newest one? Okay, so now they could just they can use that Apex Utilities menu, and it will work, and it will be shipped and tested from a QA perspective before it ships. Okay, so we got you covered there. All right, so in summary, what did we talk about? Well, we talked about a lot. Okay, we talked about pre-processing, including the new exploded view, including some new fillet defeaturing capabilities, and a bunch of meshing enhancements, including mesh flow optimization, which just gives you visually better meshes, as well as an enhanced orphan mesh workflow, including facet bodies. Lots of orphan mesh workflow enhancement in this release. Okay, so next we talked about MSC Nastran interoperability, both from a pre-processing as well as post-processing perspective. From a pre-processing perspective, we've got Nastran shared nodes across parts, which are supported, as well as vector orientation and time-based performance improvement, just improvement all around in terms of Nastran pre-processing as well as post-processing. But in post-processing, we developed a bunch of new technologies for you, including cross-section force sensor array, including multi-view and SBMT diagrams, as well as probably the most asked for capability in terms of Apex post-processing, which is Nastran OP2 file results import. We've got that support in here now. Now regarding the Python API, a whole bunch of capabilities regarding just robustness and making sure that you can use the tool the way you want it, including the new utilities menu, remote control, multiple tool palettes, lightning bolt, middle mouse, all that kind of good stuff is supported now. Okay. All right. Well, I'm going to take a deep breath and I'm going to hand it back to Mitch. And I'm going to say thank you very much for watching this video. If you made it this far, you are a trooper. And we thank you for being a customer of MSC Software and of MSC Apex. Okay. Over to you, Mitch.
Thank you, James. Great job as always. I want to extend a big thank you to the team for another outstanding release, and a very special thank you to our scripting community with folks like Larry Pierce and Stefan Tynelius, who without their help, it just wouldn't have been the same. So thank you. And so before we close, I have a question for you. Do you want to get a sneak peek at what's coming out in the next version of Apex? Our contact information is up on the screen, so please reach out to us. We'd love to hear from you about your feedback for the webinar, experiences with Apex, and if you're interested in some inside information about what's going on with MSC Apex, please let me know, and we can sign you up for our betas. All right, thank you. Have a wonderful day.